Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 2, Part 6. My top entity here says Part 5, but it is actually Part 6. And this is, again, kind of a similar one to Lab Part 5 and Part 4. But in this instance, we needed to have an input of 6-bit number going out to two 7-segment displays to properly display a 6-bit number. And the greatest 6-bit number we can do is 63. And after several hours of trying to get a variety of code to work, for instance, I broke up the binary value by hundreds, tens, and ones, and I tried to set it in a way that we would only, it would properly essentially add or increment as we change the switches. But multiple attempts failed, and I implemented if statements, a variety of different logic. But this is the one I just had left over, so I'm showing this here. This does not work properly, but it does. It's a little interesting to play around with, at least. But that's about it. But primarily, I did exactly what I said I would not do, and that was to build out this gigantic case statement of going all the way to 63 using the same setup for the BCD 7-segment decoder. The thing is, the pro to this is that it works, and it's very straightforward. It's easy to understand. There's not much to do other than copy and paste. But I don't like the thought of having to use 200 lines to get this to work. There's just something about that bugs me. It's inefficient, and I know for certain there is a better way. And in fact, there is. There's a video. I've posted the link in the description of this video. But it's lesson 34 of a different VHDL course. And I found it incredibly helpful, at least in understanding theory. And there will probably be a way to extend that to actually use it for getting those BCD values out to a 7-segment display. But I did not do that because I already spent several hours working on this, and it's something small. So I just decided, hey, let's copy and paste this, get it all the way up to 63, and voila. Aside that, there's literally nothing new or different because it's so easy to implement a structural model. So I just declare a component of a BCD to 7-segment decoder here, as I showed previously, and then I have an instance of that down here where I pass in our 6-bit value up at the top here, A, and then we have hex 0 and hex 1 to the output. That's it. That's all I did. It's simple, straightforward, probably not the best way, well, certainly not the best way to do it. But at the very least, it works. I know that's not anything any engineer ever wants to say. It works, but it's not the most elegant solution. But at a minimum, we've got the ability to display up to 63, up to the max 6-bit value. And that's it. And here's a demo. Thank you. All right, this is Lab 2, Part 6, the final part. And since in the previous lab, the previous part, I showed us counting all the way up to 31 using our 5 bits, I'm just going to count from here and go up to where we have 63 as our, using our greatest, the most significant bit here. So let's just flip these all low, and we'll see this one become 32. A magic number, if you know what I mean. But we'll just count up from here. So 33, 4, 5, 6, 7, 8, 9, 40, 41, 2, whoops, 3, 4, 5, 6, 7, flip these all down to up to 48, 49, 50, 51, 52, 53, 54, 5, 56, 7, 8, 9, 60, and whoops, 62. Well, we'll do 61, 62, and then finally 63. All right, and that's it.